Alrighty then, and one second, let's see, this is working. So it is working. Perfect. Perfect. All right. Good evening. Check one small. So you are working. That was cool. All right. So I promised last week that we were looking on some graphs. Give me a second. There. Right here with me. You're supposed to be seeing that. That's what you're seeing. That's what you're seeing. Did I give you the Pascal booklet? Everyone have a copy of that? Alright, by the end of the class I'll ensure everyone have a copy. And I just like to take graphs from it. Um that's not gonna be hard. I don't think you're seeing my screen. Oh, you're just seeing it. Alright, so that's not the screen I want. Alright. Give me a second. That's a pretty graph paper. You know that's pretty graph paper. Like I said, I didn't get the chance to. Alright. Ooh, I've several pretty graph papers. All right. We're gonna start looking at graphs. This is a hard one. You know, before I use my class, let's pick an easy graph. All right. Let's do an easy graph. Easy peasy lemon easy graph. Give me a second. I guess not. I guess that's not working for me. First time using this graph paper. All right. I'll just go back and front then. Going back and front. Share. Okay. All right. So we're gonna put as a basic graph. I want to make it simple. And let's look on our introduction to graphs. So we're looking at some introduction into graphs. Sorry for the delay. New laptop. So most of the things here are not what I'm used to. So sorry about that. So when you look at graph in physics, we're normally gonna ask you to ensure. Normally ask you to plot a graph, not a graph of say mass versus volume. We're gonna look at what does that mean. Or you might see mass against volume. They're both the same thing. That will gonna be our question one, and we're gonna use the table provided to plot a graph of mass against volume. So that'll be question one. Two, we're gonna draw a line of best fit. Three, we're gonna calculate the gradient. Four, we're gonna what? State what the gradient represents. And for crying out loud, one year I did not tell my students that gradient and slope is the same thing. So gradient or slope, same thing. And let's look at what is the value of the y-intercept. And six, what is the volume if the mass is 5 grams. Alright, so we're going to look at answering all these questions. I'm going to pick the basic, that's of the basic graph you could possibly plot. So we're going to look on, we're going to call mass right here in our table. Mass, and normally we say mass, 6, you might put an M. So the M means mass, and you're going to say a slash and G. So all this, that is going to be based on what the question is asking. So this means that the symbol of mass is M, and the unit of that mass is being measured in is in grams. Then you're gonna see something like a volume, and you're gonna see V, and you're gonna see a slash, and you're gonna see centimeter cube, which means that V means volume, and the volume is gonna be measured in centimeter cube. We're gonna put some points. We normally have 5 points. Let's put 0, 0. Let's put 1, 1. Let's put 3, 3. 6, 6. It's an introduction, so the graph is gonna be like easy, easy, and 8, 8. Have I scared anyone so far? Hello? Anyone scared? Okay, you're scared. Um, what all members in my class? Give me a second. I think people are missing, you know. Give me a second. Take that down. I want you're gonna take that down. All right. I think somebody is missing. Not sure. I tried. Oh, well, so this is what we're plotting. I think I have it. It's right in front of me now. So I'm gonna switch to my graph paper. It's kind of upside down. Well, that's it. Switch to my graph paper. Let me see what I. Oh, it's showing good. I was quite concerned about the quality of my graph paper. I still can't find my pencil, so I'm using my mouse. So I'm enjoying myself right now. All right. Under normal circumstances, when we're looking at graphs. We're gonna look on if we have any negative numbers. Mathematically, they're called integers. And if we have a learner graph paper, your mathematics teacher, don't do this to your graph paper. Um, we're gonna draw a line here, and it might draw a line here. And if you had positive x numbers goes between here, between this point, this is 0, and this goes off into positive x. And if you had negative x numbers, this negative x would go from here to here. You can put them right there. Positive y values go like that from 0 to here. That's going to be positive y. And negative y values would go from that point onto that point. Now, if you don't have if you don't have negative or positive, what do we do? If you don't have negative or positive, what we'll do is that with one mark for your graph is gonna be for the biggest possible graph you're drawing. So if you went ahead and draw east, west, north, south without any negative values, your graph is gonna be small. I'm gonna minimize this a bit. I really don't have my drawing pad on me, so forgive me, Lord, for I cannot draw a straight line. Should be a straight line, but I have my drawing pad, but I can't find my pencil. So this is gonna be that. This should be a straight line, and that is gonna be my other straight line. We're asked to plot a graph. Why didn't say that? Let me go back to that. I'm gonna go back and forth a little bit. We're asked to plot a graph of mass. Select it. We're asked to plot a graph of mass versus volume. So whatever comes first goes on your y. So mass is gonna go on your y, volume is gonna go on the x. Some people talk about independent and dependent. Really don't care about what it is. And so whatever comes first. So if they ask for mass against volume, mass. So these values are going on your y. Granted, they're the same values based because it's the ease of the graph that we want to draw. And so this is gonna be your y values. These are y values. So that's where you get that information from. And these are your x values. So you need to make a note of that. So once you ask mass versus volume, mass comes first. So that will always be a y value, and that will be your x value. So we're gonna go back to our graph. What did I put it on? Did I put it on graph? No. Crazy. So it's my graph paper. Got it. Now we had bring up our values. So I need to tell the CXC that I know that. So I'm gonna put volume here. I can use symbol V, and I'm gonna put slash um, C centimeters. I know volume was measured in centimeter cube, And I don't have much space here. Normally I have more space. I can put M, or I'm gonna put up here M slash, put it on the side for me, centimeter. So M slash grams. And then here we can put this in bold graph showing mass versus volume. And we can underline that. So if I'm marking your lab and you're marking your graph, a graph is normally 10 marks. This is gonna be 1 mark. 1 mark for that. 1 mark to tell me that that's there, and 1 mark for that. So before you even draw the mark, draw the graph, you have gained 30% of the graph. Now I like to I like to mark my graph every 2 centimeters. What in the world is a centimeter? From here, I'll put that in red so you can see. From here to here, that's 1 centimeter. So this will be 2 centimeters. This will be in three. You get the gist. I hope so. I wanted to open this in paint, So I go. I'll try it with the next graph in paint. I don't know what's happening. Alright, if I open in paint, I could manipulate this a little bit better. Um so I'm gonna put this back in blue. So I'm gonna put a stroke for each of them. So it's gonna be 0. This is gonna be what? We're not gonna put the values there. I don't want to put my marks. This should be done neater. Graphs will be extremely neat. Like I said, I don't have a drawing pad. Forgive me, Lord, for I have sinned. Um, so I'm gonna put my mark there. Let me count. The highest value for my volume was 8. Let me say 1, 2, 3, 4, 5, 6, 7, 8. So I can put 1. So I can just put 1 here, 2, 3, 4, 5, 6, 7, 8. Some students would have taken the values right off the graph, put 1, then 3, then 6, and 8. That makes no sense. Then let me put it I like to put for every two. So no matter what graph I'm drawing, I like to mark my every 2 centimeters. They're not marking exactly, but you're doing it outside, so sure you guys can. All right. Let me see. I can put 1 here, 2, 3, 4, 5, 6, 7, 8. So I'm gonna pause, and you're gonna ask you guys what was your last week, the paragraph paper. Mark a graph, make sure it's neat in mind, and we'll give it 5 minutes to get that done, and then we're gonna move on into our next part of the graph. Yeah. Yeah. It's all right. Are you guys with me, Steven?
Yes, sir.
All right. So we're gonna plot some points. Sorry for my. All right. So let's plot it. So our first point is gonna be 0, 0, right here. Zoom in. Please make yours neater. Then I'm gonna have 1, 1. So it's gonna be one here, one across, one up. And where those both of them intersect, you put an X there. Then you're gonna have three, three across, one, two, three, and three up. And you're gonna put across there. Then you're gonna see six, so it's gonna be six across and six up, and put across there. And eight, eight, you're gonna go across the eight and then go up and you put across there. So that is gonna be, so what's gonna happen? Oh, you grade this. One mark for this, one mark for this. So one mark for the title, one mark for this, one mark for this. Having a graph that is more than half the graph is one mark. So you set your scale on both axes. That's 4 marks. 3 marks. That. Give me a second. 3 to 5 marks for drawing that. And then one thing. we need to draw a line at best width. I don't have a ruler, but give me direct should be a straight line using a ruler. If I had my drawing pad, I could have put a ruler against it. Anyway, I'll try my best. It can go through all points. Sometimes line of best width doesn't go through all the points, but it can go through the points. So draw a line straight. This is a 12-inch ruler, clear ruler, and this graph should go through all the points. And this is a rough sketch. Sorry for the roughness of my graph. And that's how your graph should look. And if your graph is neat, you could have gotten a 10 mark. And that's a basic concept of graphs, drawing a graph. So plot those points, send them individually, let me see them, and so plot that send individually, and then we're gonna move on. So if you know my number, and one person. So send that everyone. That is what's happening, and then we're gonna move on and calculate the gradient. Alright, I only got one graph so far. What's the issue? Other students? We have anyone else? Only got one.
Sir, just reached home soon. I'm gonna try to look for the graphic lesson.
You guys want me to leave and move on to the next part? And then later in the catch up?
Yeah.
Alright. So, like I said, yours should be neater than mine. Sorry about it. I normally have a drawing pad. I could have done it, but anybody want to buy me a pen? If anything, I'm gonna look for the pen. Right. But I'm recording my session though. So, um, but I have to edit this a little bit. Let me see if I can do this. Alright, next question. Our next question. After to calculate the gradient, how do we do that? Ooh. So normally, so there are two ways I can do it. You have the incorrect way that you're gonna lose one mark, and you have the other way. Depending on what the type of students I'm teaching, I'll let them do it the incorrect way. But then lose one mark, then get no mark. Right? So by right, if you're really good maths, you can pick one of these. So you pick one of these and two of these points to get to calculate the gradient. You lose one mark, but if you know you can't do that part here, pick two of them, any two of them. If you want to pick them, you pick that one here and pick that one here. This method will make you lose one mark because you shouldn't be picking the points that you have plotted on the graph. So you have plotted 5 points actually. This one you plotted 5 points. You should not be picking them. But if you can't read off any points, pick them. Lose one mark and move on. If no matter what, you can pick them, but you're gonna lose one mark. So that's up to you and God. Now, the correct way of doing it is this. You're gonna pick 2 points that are not plotted, that are far apart. Let me try to use yellow. So I'll pick this one. Maybe I'll pick this one. This one looks okay. This one looks sweet. Now, yellow is a bad color to use. Red looks better. Or purple. Pick this one. And I like to use a different subject. So this is gonna be 7. I like to write it on the graph paper to remember. Come slow. 7, 7. And this is, I'm gonna label this. I'm gonna call this one x2, and I'm gonna call this y2. You don't have to do this on a graph. I like to do it on a graph in pencil, small, and I can pick this one. And then I'm gonna call this one 2. So it's when I read it, so how would I get 7? I look at the value here, so, and that is 7. And I put this 7 right here, and then I look at the value down here, and that was 7, and I put that value right there. So that's where I was two values from. If you didn't see. For this one, I need to read off the value right here, and that's 2. Well, that is this 2 at the end, and I also read off this one here, which is that 2. X values for this is comes first. That's mathematics. So this I'm gonna call this y2, and I'm sorry y1 subscript, and I call this x1. This is normally done on the back of the graphic, but do not do this. I'm just doing it because it's in front of me. You will normally use the equation m is equal to, right in the right equation is 1 mark, y2 minus y2 minus y1 over x2 minus x1. We also draw a large triangle. This is one mark. It's normally a 4 or 5 mark question, and you put in the values. We said that y2 was 7 from right here. That's 7. And we know that y1 was 2 over x2, which was 7. And this was 2 as well. We're going to put 5 over 5. That gives me 1, 1. And I need to put a unit. My unit at the top for y was grams, which is right here. And I put grams. And then my unit at the bottom is centimeter cube. So I put centimeter cube right there. So that's grams per centimeter cube. So when I'm marking this, normally I give 1 mark for drawing this large triangle, 1 mark for reading off these points. Sorry, 1 mark for writing the equation, 1 mark for reading the points, and 1 mark for getting the answer of the correct unit. So it's normally 4 marks. Say it gives 5 marks these days. I need to know where they get that extra mark from. And having that would have given you 14% of the exam if you have drawn a graph. We normally put this on the back of the graph. So try that and calculate the gradient, and everyone should get the same gradient of 1. So you're going to do that on your graph and let me know. Miss, I forgot about Elton. Give me some more. Alrighty then, you guys always there. Good? Check. Alright. Alright, another question. Calculate the gradient and slope. What does the gradient represent? You may not know this, but what happens is that the gradient represents density. And how in the world do I know that? I'm looking on the SI unit. Later on, you guys are gonna know this. Looking at the SI unit, and the SI unit is gonna be grams per centimeter cube, and that's density. And pretty much, to be more accurate, it's the density of water. And later on, so when you are asked what the gradient represents, you look on the unit. That's how you answer that question. So next question is gonna ask what the y-intercept. What in the world is a y-intercept? Make a note. The y-intercept is the point where the line of best fit you have drawn touches the y-axis. So that blue line here, from here to here, and my y-intercept is right here. So my y-intercept would actually have a value of 0. So you can write for this graph. The y-intercept is where the line touches the y-axis, the line of best fit, and this is going to be 0, and it's not going to be dry 0, it's going to be 0 grams, because the value on the y-axis is grams. Last dry question, question 6. And what is the value when the mass is 5 grams? So what you do is this. You find 5 grams, so this is grams here. You're going to draw a dotted line, go over. You're going to draw a line and go down. And therefore, that answer is going to be equal to 5 centimeter cube. So that's 5 centimeter cube. Make a note of those two. I'm going to move on to another graph that has a bit more oomph in it. Yes, Miss Elton, are you hearing me? Yes, Miss, I'm sure I should be here. I'm in the wrong class? I wondered, am I in the wrong class? You know, Miss, I log on to the wrong program. Bye, Miss. It's more of a moment. Oh, sorry, sorry. All right. We're finished with that one. We're gonna try to let's try to take it a step further. Um, where am I? I have no idea. Oh, yeah. I didn't know why I did my turn change like that. All right, so we're gonna let's go to the big league. Are you guys ready?
Yes, sir.
All right. Look for an easy one. But there's no easy team magic in physics. I like this graph. Um, take this. Stay down the values. Don't plot the graph. Stay down the values for me. Graph is select some people, but later I'll look at it. All right. So take that down. Give you. Let's write it down, and then I'm gonna do not start a graph. This graph is a good graph. So after you take it down, let me know. Give you 2 minutes. Take down the value. That's the values I want to take down, and then we're gonna start. Alright, so sure you guys finish taking that down. So this is how you're gonna draw your graph. So draw your graph like this is how sexy say you want to draw your graph. So sometimes you need to read the question before you start drawing a graph. Alright. So you're gonna divide the graph like this. So just do that, so we can start. After you take that down, everyone is finished. Hello, it's me. I've been wondering if you're finished with that activity. Hello, you guys hear me? Hello. Oh, yeah, just give me thumbs up. Okay, I'm getting thumbs up. All right. So let's get the show on the road. Now we're gonna plot. So we're gonna read as well. We're gonna look at this. We're told here that you're gonna put six. Actually, sorry for you. You're gonna put volume on your y and temperature on your x, and on the x-axis you should have a range of negative 300 to positive 300, and you use 50 um 50 what name degrees Celsius. How in the world would you do that for a division? Alright, I'm sure. I'm gonna give you this one. So up here is gonna be 0 every division. So these are division, so this is gonna be 50. And they told us to put what did we put? Was it temperature? Yeah, it's temperature. So you're gonna label it temperature, and then tell you the temperature in degrees Celsius, and you're gonna put the volume. What's the unit of the volume? Volume in centimeter cube. So this is gonna be volume in centimeter cube, and you are gonna give your graph a title, all capital, graph. Okay, let's spell graph showing mass. Sorry, volume versus temperature. Hope that come out properly. So that will spell temperature all of a sudden. I'm gonna pray autocorrect save me. Autocorrect. Temperature is beating me right now. Okay, good autocorrect. We're gonna underline that. Make sure on all our graphs to do that, no matter what. We're gonna come back down here and we're gonna put 100, and then you're gonna have 150, and then you're gonna have 200, and then you're gonna have 250, and then you're gonna have 300, That's what I said for every division, right? And then on this side, you're gonna have negative. Well, I'm just gonna skip it. You can call it negative 100. By right, I should have 50 right there, but I don't have space. And I can say negative 200. And I'm gonna have negative 300. So that's what CXC meant by that. I'm gonna zoom out so you guys can see what's happening. So zoom, well, that's the top. So you can take out the top. After you take the top, I'm gonna go down to the bottom so you can get that. So give the graph a title and name the axis. Alright, almost have finished with that portion. Come down to the bottom. Each of them should be 50. So 50, 100, 150, 200, 250, 300. Then you're gonna have negative 50, negative 100, negative 150, negative 200, negative 250, negative 300. And that's the unit right here. So just plot that, well, don't plot that, just write that and let me know. I'll give you 2 minutes to do that and we can move All right. Ready? All right. I just post that. Let me see. It's gonna be a little interesting one. So now we have a problem. So we need to find a temperature of 20. How would you find a temperature of 20? Let's look here. So notice between here and here, there are 5 spaces. But between here and here is 50. What I can do, I can divide this here by 5, which means this would be, each of them is value 10. Does that make sense there? I've not, I have not put the unit here. I'm going to put 10 on this one. This is going to be 20. This is going to be 30. This is going to be 40. This is going to be 50. This is going to be 60. This is going to be 70. This is going to be 80. And that's going to be 90. How in the world did I not use 1, 2, 3, 4 like last time? How did I arrive at that and look at these numbers? I notice that these numbers, this is like, this is called this 50, right? Or we can call this 40. And then we'll call this 50. I will call this 60. And we can call this 70. And this is going to be 80. But I had to start from 0. So it's going to be 10, 20, 30, 40, 60, 70, 80. Are you guys seeing that? So I know that this is 50 or 40. And I know that this is 50, 60, 70. And I have to go up by the same value. I cannot put 41 point. I can put 49.1 on the graph. And then I put 50 somewhere. I have to put all numbers. So I know that this is pretty much going up by powers of 10. So when I'm picking my scale, I went up by powers of 10. Hope that makes sense to you. Now, I want to plot a point. So the first point is going to be 20. Whenever I want to find 20, it means that each of these value 10 on this one. This is going to be 10, this is going to be 20, this is going to be 30, that's going to be 40, and next one is 50. Let me know if that makes sense there. And how I look at that, I look at this is 0, there are 5 spaces between here and here. I count them 1, 2, 3, 4, 5, and this value here is 50. Now, let me do it for this one now. Between here and here, there are 10 spaces. and this is 10. So what I'll do is divide 10 by 10, and I end up with 1. So each of these value 1 and each of these value 10. Are you seeing that? And that's called finding the smallest division. I'm gonna take some time, try to wrap your mind around that. Let me know if it makes sense. Count it if you don't believe me. Each of these value 10, count from down at the bottom here, so and count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And count by 10, 20, 30, and see if you don't get 50. And no matter what point you want to find, it stays the same. That's why we use the same spacing.
Whichever one we can make sound very bash. If we can find the right tune for a jingle, if not, we'll just do the poem. Hello. Is it possible to meet and do a run through before class? Have something organized? It did not start off as a poem when Elton do it. He did it as a jingle, but I asked to add a.
Okay, Jean, understood.
I must say it would be bad as a dub poet. It would be.
Everyone understand what I just did and why I did it? Let's go through it again. Why did I pick 10? Let me go through it again. When I look at these numbers, they lend themselves to 10 easily. I need numbers, so when I'm going to pick a scale for my graph, I can use 1, I can use 2, I can use 3, I can use 4, I can use 5, or I can use 2, I can use 4, I can use 6, I can use 8, or I can use 5, I can use 10, I can use 15, or I can use 10, I can use 20, and I'm going to look at my numbers. These numbers do not lend themselves to that because I cannot reach up to it. If I'm supposed to put 1 on it, it can't reach up to 80 or there. So I cannot pick that scale on my y-axis. The numbers also, these numbers here, these numbers I'm talking about, would not lend themselves also to 2, 4, 6, 8. So I cannot pick that. 5, 10, 15, 20 is too small. So I can use 10, 20, 30, and that's why I picked 20. That's why I put 10, 20, 30, 40. I did not have to worry about my x-axis because 6 told me exactly. Every division, which is every 1 centimeter, put 50. And that's exactly what I did. Now what I need to know, I need to plot my first point, which is going to be on my x-axis. I'm going to write it down. On my x-axis, it's going to be 20 for my x. And for my y, it's going to be 49.1. So now I need to know what each of these one things value. So I'm going to look between here. I'm going to look between here and here. I know that there are 5 spaces between them, and this is 50. And I can find out by dividing that by 5. So therefore, each of them values 10. This is between here and here. This is 0. That is 10. And this values 10. So I can divide, and therefore each of them is valued 1. And we're going to use that information now. So I need to find 20 and 40, 41. So 20 is going to be right here, 10, 20. So that's 20. And I'm going 10, we'll find 48. It's going to be 20. It's going to be 30. It's going to be 40. And I want 49. I'm going to count all the way to 49. This is 50. I don't know what it looks so bad. It's going to be 49 and it's 49.1. So I put it just above 49. I do want to mark 49 and I'm going to estimate where point 1 is. And that's my first mark, 49.1. My next mark is going to be 54. So it's going to be 54 on my Y. I'm checking, and on my X, it is 50. So 50 is right here. I go across and find 50, and I go all the way up to 54, and I put an X at my 54. Try find those 2 points and let me know. I'm gonna give you um 2 minutes to find those 2 points, and then come back to you. Hmm?
Boy, sweet. I thought that we were supposed to be going to everybody seemed to be making PowerPoint. Can I share? Oh. Shoot.
All right. So that's where you guys are supposed to be. So I'm gonna erase this now, and I'm gonna move on to the next point. Where are we? Where are we? I am supposed to be somewhere. Let me find them. My next point I'm gonna plot is gonna be 100 on my X and 61.3. So we're gonna go find. So we're gonna go down here. We're gonna find 100. We're gonna go up, and then we're gonna go 10, 20, 30, 40, 50. We go to 61 is right here, and point 3 is just above 61, and that is that point there. The next point is gonna be 157 point 150. So it's gonna be 150. I'm gonna go down to 150, and I'm gonna go up to 70.05. 70.5. So it's gonna be 70 is right here, 0.5 is gonna be halfway. You're gonna put up X there. Next one is gonna be 200. Find 200. Go up. And it's gonna be 280, 89, 378.9. So it's going 75, 76, 77, 78, 78, 78.9 will be close. And next one is 250, 250 and 87. So it's gonna be 85, 86, 87, And then after you've got that, you're gonna draw a line of the split. So you're gonna draw a straight line, and this line should come all the way down here, around there. So draw that line. Sorry for my line not being straight. Um, so it should look something like that. So I'm gonna give you how much minutes you guys need to finish this up. So I'm gonna give you 5 minutes, and you're gonna send a graph to me. Let me view it.
I was just locked out of my Microsoft PowerPoint. Can anybody do it?
All right, I got it from one. You guys need more time to finish up. All I got from one so far. Hello. All I got from one person so far. And there are one, two, three, four, five, six, around six, eight guys in here. And I only got from one person. You guys okay? Hello? So, all right, you're okay. Where is the graph?
Sir, I don't have any graph papers, sir.
All right, cool. All right. So that is that. Um, I'm gonna finish right here. You're gonna finish with the graph. Please don't draw a graph directly onto 300. So finish this graph up. I'm gonna finish these questions later on. I'm gonna give another graph to do. I will just come into next class regarding that. Give a next graph. This is a nice graph. So you're gonna have two graphs here. It's gonna be homework. All right. So this graph, I like this graph. I picked this graph for a reason. Reason why I picked this graph, it most of the time before you do a graph, you have to analyze. And in analyzing a graph, you need to pay attention to a few things. Sometimes you don't even say you don't even give things you know about. What's gonna happen is that force is equal to mass times gravity, and mass should be in grams. So notice that this is mass, but it's not in grams. It's not in mass should be in kilograms. So it should be in mass should be in kilograms, but this mass is in grams. So we have a problem right here. And also, we don't know what extension is. So pretty much extension is the added length from the original length. What in that? So the original length of the string is 60 and the added length is 60.5. Therefore extension is 0.5. Your original length is 60 and we add weight to it, it becomes 61. Therefore your extension is 1. Your original length was 60. We add more weight to it, it becomes 61.5. Therefore, extension is 1.5. Your original weight was length was 60, then it becomes 62. Therefore, your increase in length is 2 and you put 0.5. Your original length is 60. You add more weight to it, it becomes 62.4. Therefore, your added length is 2.4. Your original length is 60, you add weight to it, you add this weight to it, it becomes 63, therefore your extension is 3. Does that make sense to you? So your original weight length, and you're going to have a new length after you add mass to it, or you're going to add force to it. And that's what extension is. So you need to know these other things. We're going to look at this as an experiment later on. I just want to look at the graph right now. So that's how you'd have figured that out. So your original length is that, your new length is that, therefore this was added to it. So I subtract 60 from this and I get 0.5. You think me to calculate out this? Yeah, grade one, correct. You need to come on TikTok and IG and never go back on never go back on social media. You should be able to do this out your head. Alright, what's gonna happen here now? You're gonna divide this by 1,000 and multiply by 10. So I think divide by 100. Anyway, do that. My math is bad right now. I think this is gonna be point two. This is gonna be point four. This is gonna be point six. Later we'll talk about the calculation. This is gonna be point eight. This is gonna be point one, and it's gonna be 1.2. So what's gonna happen? I'm gonna, to convert from grams to kilograms, I have to divide by 1,000. So I divide this by 1,000, and then I multiply by 10, and then I divide by 1,000, divide by 1,000, and I multiply by 10. Let me know my calculation is wrong or right. So divide 20 by 1,000, and then multiply by 10, and you're gonna plot the graph of that. So you're gonna plot a graph of extension against force. So extension is gonna go on your y-axis, and force goes on your x-axis. Um, Next class, I'm gonna go through conversion a little bit deeper for you, and I'm gonna look on this. I'm gonna play out. We might do a simulation of this, or we're gonna watch a lab on it. So when you actually have an idea of what I'm talking about,
Sir, watch out what, sir?
a lab. We're gonna watch a lab,
Oh,
so you know what I'm talking about. Sometimes when you can visualize something, you're able to understand it a little bit better. So finish that. Finish. So you have draw this graph at the top. You're gonna draw that graph, and we have some questions to answer. And then if you after we go through that one, we're gonna go through this graph, and when we go through this graph, we're also gonna talk about the lab. This is a lab that CXA expect you to do. It's actually called Hooke's Law. So it's a Hooke's Law lab. It is a classic lab. Hooke's Law. It's a classic lab. It's one of the lab that comes a lot. And there's a trick in behind this question. There's a trick behind it. We're gonna see what happens. Why there's a trick in it. This is the trick. We're gonna talk about why that is so, and we're finished with we're not finished with graphs, but we're finished with our introduction to graphs. But graphs are gonna answer for the rest of the year. All right, guys. I'm gonna